So a couple of years ago, as just an exercise to end class with, I had my students take out a piece of paper and write down everything they could think of that you could do to a rock. And I did that. You'll see why. And I organized them afterwards, and I was not disappointed with the creativity of my students, which is pretty normal. But I wanted you to see what they came up with and maybe understand a little bit about why I don't offer this assignment anymore. So, first, my students said that you could melt a rock, you could weld it, you could heat it, you could set it on fire, blow it up, or microwave it, which are all weird things to do to a rock. But regardless, if you do any of those things to a rock, you would form what's called an igneous rock. And so we'll talk a little bit more about this in just a second. So the next list of things that they said you could do to a rock are right here. You could apply heat and pressure to a rock. You could season a rock and bake it in an oven. You could compress it, heat it, mold it, shoot it, or electrify it. And if you did any of those things to a rock, you would be making what's called a metamorphic rock. And then there's a very long list coming up here that fell into a different category. So you could dissolve a rock, you could chemically alter it, you could combine it with other rocks, you could burn it with acid, you could grind it, you could cut it, you could glue it to a wall, throw it at a train, you could erode it, bury it, polish it, leave it in running water, you could throw it off a cliff, you could just throw it, you could clean it, you could paint it, you could scratch it, you could swallow it, cut it, freeze it, submerge it in water, and dry it out. I would recommend very few of those things, incidentally. But if you were to do any of those things to a rock, you would be forming a sedimentary rock. There were a few things that did not fall into any of these nice little categories, and this is the reason that I no longer offer this assignment. You could dress a rock, you could love it, or you could rub it, and those don't fall into any, honestly. Although I suppose if you rub a rock enough, you could break into sediments, and then it would be a sedimentary rock. So regardless, you can't get through a physical geology class without talking about rocks. They are pretty much what we do for the first quarter of this semester. So let me give you some more formal definitions to go along with those three rock types. So igneous rocks. Igneous rocks are one type, then we have sedimentary, and finally metamorphic rocks. So igneous rocks form from the cooling and the solidification of molten rock. So rocks can be molten inside the earth and cool. And when we have molten rock inside the earth, we call it magma. And rocks and magma will sometimes erupt onto the surface of the earth, and that's when we call it lava. What you see in this picture is actually a picture of a 2,000-year-old lava flow. This is actually in Idaho. Idaho has a tremendous amount of igneous rocks. They had a lot of igneous activity in the last handful million years. And so this is a lava flow that cooled, and you can kind of see with the orientation of some of the ripples here which direction the lava flow was moving when it cooled. So again, those are called igneous rocks. So sedimentary rocks are pictured here. Sedimentary rocks are formed from pre-existing stuff. You have the cementation of eroded material. Maybe it's been eroded from another rock. Maybe those particles have been transported by streams or by wind or by ice. And then you have particles that are dropped or deposited. Maybe as streams slow down, they deposit particles. So all of these examples are ways that sedimentary rocks can form. So sedimentary rocks are pre-existing sediments. It can be gravel, it can be sand, it can be mud. And that material comes from another rock, and it's been broken off, transported, and cemented together. You can see a really famous outcrop of sedimentary rock in this picture. This is called the Wave. It's actually right on the border of Utah and Arizona, and I've never been there, but the Wave is named for the really great tilted sandstone layers that you can see here in this picture. It's a really well-preserved place, and it is only accessible by about 30 people a day and by permit only. And so what you see here are layers of what's called the Navajo sandstone. And that's an example of sedimentary rocks. So if you apply temperature and pressure to an existing rock, you can form what's called a metamorphic rock. The existing rock is called the parent rock. You apply temperature and pressure to the parent rock. You don't apply so much temperature and pressure, though, that the rock melts. All of this happens in the solid state. Rocks can sometimes get a little bit plasticky, but overwhelmingly, this all is occurring in the solid state. And the parent rock will metamorphose into a metamorphic rock. We'll be doing chapters on each one of these rock types, so we'll talk about it in a lot more detail in the future. What you're looking at here in this picture is just a picture of some marble that has been squished, and you can see some of the darker layers and then some of the more characteristically white layers of marble in this picture here. So we're going to do a little, you're going to watch me sketch out the rock cycle for you. And so that'll show us how when we change some environmental conditions, we can actually change rock type.